Okay, so let's make a start. In terms of what we're doing today, is we're going to be covering something that we had briefly touched on last lesson, which is speed, what speed is, and now we're going to be focusing on distance time graphs, which is related to speed. So, before all that though, one key bit of knowledge that you need is something from your maths lessons. And now I know that maths, you've done like graphing before, and you would have also talked about something called the gradient, also known as the slope. It means the same thing. So gradient slash slope. And this key word, gradient, is basically just like a measure of how steep the graph is. And hopefully back in maths you'll remember that in order to find the gradient, so the steepness of a graph, you do rise divided by run. And rise is the change in the y-axis, how far it moves up or down, and run being the change in the x-axis, how far it goes across. So just like a quick example, let's say that we had a graph. I'm going to do it like this. There's the 0 point, and here's a graph. Let's say this is 4, and this is 2. I know this is wonky, but forgive my scalings. So with this gradient, the change in y is that it went up 4, and then it went across 2. So the slope would be rise was 4 over run was 2, and 4 divided by 2 is 2. So the overall slope is going to be 2 in that example. And if this was like 6 and then 4, then it'll be 6. It'll be, if this was 6 and this was 4, then it'd be rise is 6, run is 4, and the overall gradient would be 3 over 2 or 1.5. But basically the gradient, which is the slope, exactly as you've done in maths previously, is the change in the y-axis, how far it went up or down, and then divided by the change in the x-axis, so how far it went across. So this is a key point that I want you guys to understand when we look at distance time graphs. Okay, so with a distance time graph, it is basically just distance and time. So the x-axis is time, essentially. So as time goes up, so let's say this was 0 seconds, 1, 2, 3, 4, 5. And then D stands for distance. So this is the y-axis represents distance, how far the object has moved. Let's say this is 1, 2, 3, 4, 5, 6, 7. Okay. So let's have a look at this graph and think about what it's showing. Because distance time graphs, basically what they are is we have an object changes its motion, it starts moving around or it's stationary. Can we represent the motion of this object in the form of a graph? And the way we do that is with a distance time graph. There's other types of graphs that if you look up yourself you might see, like velocity time graphs, but just for year 8 we're focusing on distance time graphs. So this is all to represent an object's motion, basically. That's what these distance time graphs are for. Now let's have a look. Okay, time is moving forward. It's going from 0 seconds to 5 seconds later. And the distance the object has traveled from its starting point, or the distance the object has traveled, is still 4 meters. It's staying on 4 meters or staying on 4 as time goes on. So if you were to think about this, have a think about what this object is doing. Picture it. We have a starting point of 0. It had been at 4 meters away from its starting point. Time carried on, and it's still on 4 meters. Have a think about what the object is doing now. It's still staying on 4 meters as time is moving on. So let's do multiple choice. Let's say I'm going to give you some options. One of these is going to be right. Let's say moving, speeding up, slowing down, stationary, which means still, and then ignore this last one. Which one of those, if this was multiple choice, which one do you think it is? Well done, Florence. It is stationary. For a distance time graph, whenever you see a flat horizontal line like this, that means that even though time is moving, the distance hasn't been changing. So, whenever you see on a distance time graph a horizontal point where it's just flat, it means the object is staying still. We call that being stationary. Right, now let's have a look at another one. Okay. So here's this distance time graph. Time is always obviously going to be flowing forward. As time increases, let's add some numbers here to make it easier to visualize. As time is moving forward, we do have an increase in distance over time, right? So at the start, it was 0 distance, 0 time. Then, let's say 1 second later was 1, 2, 3. So as time is moving forward, the object is also moving. Once again, I'm going to give you multiple choice. Let's go that. This one might be a little bit tricky. What do we think? Spot on. It is moving at a steady pace. And for those of you who didn't work this out, let me explain why. Okay. So, remember what I said earlier about gradient. Let me change the color on this. Remember what I said earlier about gradient. Gradient, which is the slope, is equal to rise over run, rise being the change in x over the change in y. Well, the rise being rise over run being the change in y divided by the change in x. Sorry, I misspoke. So change in y, let me write that down, y over x. So what is y in this case? Well, in a distance time graph, the y-axis is distance. And in a distance time graph, the x-axis is time. Think back to last lesson. What other thing do you know is distance divided by time? Think back to last lesson's formula, guys. Speed. So basically, in a distance time graph, the gradient, which is the slope, When you calculate for gradient, you are calculating the speed. So when, just like you do in maths, you calculate for rise over run, in a distance time graph setting, because remember physics is just maths with an application, like maths in a context, whenever you calculate the slope, it's a speed. And if you look at this graph, is the slope changing at any point in this graph? It isn't, right? Because it's a straight line. It's a straight line, so like the slope at this point, how steep it is at this point, is the same as how steep it is at that point, and it's the same as how steep it is in this point. Because the line isn't curved or anything like that, and we have a straight diagonal line, the slope is the same the whole way through. And because the slope is the same the whole way through, the speed is the same the whole way through. And the reason why is because of that fact that in maths, gradient is rise over run, or y over x, and in a distance time graph, y over x is distance divided by time, which is speed. So notice how we're linking now what you have done in maths to a physics perspective. So let's with the numbers that I calculated here, let's actually calculate what the speed is. Okay, say it went up 3 in about 3 seconds. Whoops. So the change in y, it went up 3 in 3 seconds. So 3 divided by 3 is 1. So the speed in this case is 1 meter per second. So you can find the speed using a distance time graph. Now I'm just going to quickly do something else. Let's pretend we had a distance time graph with 3 objects on there. Let me use different colors for all 3 of the objects. We'll stick with red for object 1. So let's say we have, or A, pretend that is a straight line, guys. We use rainbow. B, and then that one. C. And then this is distance, and that is time. So let's have a look at this graph. Say this graph is 3 different objects, all mapped onto the same distance time graph. So we have object A, object B, and object C, and they're all moving at different speeds. Which of these objects is the slowest? Thanks, Max. Very good. Object A is the slowest. Now, someone besides Max, which object is going to be the fastest? Very good, Florence. So, basically, for those of you who are sat there feeling a little bit confused, where you're not sure why A is the slowest and C is the fastest, once again, think back to maths. C is the steepest line, so its gradient is the highest. Its slope is going to be the highest because it has the biggest rise over run. B's in the middle. For A, the gradient is the lowest because it's less steep. So lowest steepness, I'm going to say, because it's not very steep at all. It has a very small rise over run. And remember, gradient in a distance time graph is a measure of speed. When you calculate for gradient, you are calculating the speed in a distance time graph. So if the gradient is the highest, the speed is also going to be the highest. And if the gradient is lowest, the speed is also going to be the lowest. And then B is obviously in the middle. Okay. Right, we're on to two challenging ones. Now, describe the motion shown in this graph. One thing I want to point out to you guys is, as you can see, the slope is not the same the whole way through. The slope at this point, it's like not very steep at all, right? It's not going up by much. Gets steeper as it goes on. So like the point by here, the slope is the steepest. So the slope is different at each point in this graph. So my multiple choice, stationary or same speed or speeding up or slowing down. So keep in your head when you're answering this one what the gradient represents, what the steepness of a distance time graph represents. Speeding up, very good. So let me just re-explain with process of elimination. Well, it's not stationary. We know it's not stationary because its distance is changing over time. If an object was stationary, the distance wouldn't be changing at all. It's not the same speed because if it was the same speed, it'd be the same gradient or it'd be the same slope the whole way through. And because it's not the same slope the whole way through, we have a low slope here, a medium slope here, and then a highest slope here. It can't be the same speed. Otherwise it'd be this shape where it's the same gradient the whole way through. It's not slowing down because we see that at this point the gradient is the lowest, and at this point the gradient is the highest. So if it went from a low speed to a high speed, it can't be slowing down, it has to be speeding up. So whenever you see a curved graph, that means that, number one, you should see a curved graph and a distance time graph and think, okay, curved, that means the slope is changing, so that means the speed is changing. Now, then think about whether the slope is increasing or decreasing, and that is going to tell you whether the speed is speeding up or whether it's slowing down. All right. Last one. Describe the motion of the object shown in this graph. Slowing down. Very good. And once again, it's not stationary because the distance is changing. I mean, it's maybe kind of becoming stationary at the end there, but in the entirety of this graph, distance is changing, can't be stationary. the slope is not the same the whole way through, so it can't be the same speed because speed equals slope. It's not speeding up because look, by here, the speed is the slope is the steepest, so the speed is the highest. Then it levels off over time. So in this case, it is slowing down. So my goal really is for you not to need to memorize all of these graph shapes because we have 4. 1, 2, 3, 4. We have a horizontal flat line. We have a diagonal line but is straight, not curved. And then we have 2 sets of curved lines. I mean, with some of you, depends on your style, but with some of you, you might feel like, oh, I want to just memorize it. I just want to know flat line, stationary. I want to know straight, diagonal, same speed. That's fine if you just memorize it. However, I want you to also understand that you can work it out as long as you remember that the slope is the speed. As long as you remember that, then you can work it out without needing to memorize. And now let's go back to the first graph. Remember, slope is the speed. Is there any slope on this graph? No, right? Because it's completely level. The slope is 0. So the speed is 0. Same principle applies. Okay. Now, let's go on a bit of practice and some examples. Okay. 1 second. Let me just give you guys the links to stuff. All right. So here's the link. I'm going to go through basically what you need to do on this sheet. So give me 1 second. Let me just change the window that I'm streaming to make it my Microsoft Word browser. Give me 1 second to find that. Okay, there we go. All right. So, if you go on that website and you scroll down to 9i Forces in Motion, there should be a third folder called Distance Time Graphs. When you click on it, you'll see 2 things. The first is a sheet. The second is a PowerPoint. And the PowerPoint is basically what I'm using now, but there are answers to that sheet at the end of the PowerPoint. So I'm just going to quickly go through what you need to do in terms of applying that knowledge to the questions. Let me zoom in here. 1 sec. View. One page. Okay, zoom in. Right, so the first set of questions, it asks you to do a bit of calculations, but it's not, what I want you to understand is that it's nothing different to when in maths you're asked to find the slope of a graph. Except obviously in physics, we have the slope means something, it means the speed. So when I say find the speed of the following, I'm essentially asking you to find the slope. And you have to remember for this section, the slope is equal to rise over run. So you have to sort of calculate with each of these the change in the y-axis divided by the change in the x-axis. For the second set of questions, this is a little bit trickier because remember the change in y is that bit. The change in x is that bit. So as you can imagine, one common mistake a lot of students make is, let me make that mistake now. Right, so rise over run. This is me doing it wrong, guys, so don't do this and then think that this is the right way to do it. Okay, I read the y-axis, I see it's 20. Read the x-axis, see the graph ends at 6. So I know the graph ends at 20 and the x ends at 6. And then that's my answer, rise over run. That is a mistake because the rise, it did not start at 0. So me using that 20 number is incorrect. I need to be looking at how much it went up by, because that's what the rise means, not just whatever number there is on the x or y axis. I'm looking for the rise. So in this case, I'm looking for it went up from 5 to 20. So the rise was 15 divided by how much it went across by, went from 0 to 6. So the run is 6. Now, question 3 is a little bit more challenging because it asks you to actually draw the lines. I'll do the first one with you guys just to get you on the right track to model how to do it. So in the space, draw lines to show the motion of an object that travels 60 meters in 5 seconds. So 60 meters went up to 60 and it did it in 5 seconds. So it did 60 meters in 5 seconds. I'd like to put a little dot by there just to show. And it starts from 0 and 60 meters in 5 seconds. That is a constant speed, right? It did not tell me that it was speeding up or slowing down. So it's going to be a straight line from to 60 meters in 5 seconds. Now have a go at the next two. Now, this is the biggest challenge. Look at the distance time graph of a motorbike and then answer the questions. The sudden changes of speed on this graph are not realistic. Obviously, I had to include that because I didn't want you to think, hang on, it can't just go from a constant speed to not moving straight away. That's not realistic. Yeah, don't worry about it. So you have a few questions that are basically asking you to analyze and read through the graph. So this bit is less, or has some calculations, but it's more like here is a distance time graph with a lot of stuff going on. Its motion is changing the whole way through. Notice that it doesn't look like one of our 4 graph shapes, but it's a combination of those graph shapes. So for how long is the motorbike at rest? So this is testing you to know, what does the graph look like when it's at rest? What does the graph look like when it's not moving? And then reading off to see how long of a time that took. What distance has it traveled in the first 25 seconds? Reading it from the actual graph itself. So question 4, this is the hardcore challenge. If you struggle with this, that is absolutely understandable because question 4 is a GCSE level question in terms of analyzing a graph. So do the best you can on it, but don't worry too much if you struggle a lot on it. But obviously, if you are motivated, where if there's a particular one of these questions under question 4 that you feel like, oh, I really do want to know how, I really do want to understand this question. Can you re-explain? I'm happy to do so. But in terms of what I expect from you right now, I do expect you to try to find the slope, be able to find the slope. I do want you to be able to relate a speed and then draw out a graph yourself, kind of. And then for this is do the best you can at being able to analyze what is happening in this graph, but don't worry too much about it. If you get half of these questions right, you're in a really good place because that's half of a really difficult GCSE question that you would have gotten correct. So have a go at that on that website that I've just linked. In the PowerPoint, I have the answers at the bottom of the PowerPoint divided in the questions. So the first slide has questions 1 and 2. I've put it in decimals instead of fractions, and then question 3, and then question 4, along with the mark, so with the mark scheme of for the ones that have multiple marks. So if you're not sure how I got one of my answers, send me an email or leave me a comment on Show My Homework, and I'll try to get back to you as soon as possible. All right? Okay, guys, so that's it. It's a short one today, but it's one where it's not much me explaining stuff because a lot of it has already been done in maths. It's just me taking what you did in maths and applying it to a physics context. And then it's just practice for you to analyze graphs a bit. Alright, so do the best you can. You don't need to submit it to me, but hopefully it'll improve your confidence with these types of graphs. And have a good rest of the day. Enjoy. Bye.